In this video, we're going to talk about SURD. So we will talk about addition, subtraction, and multiplication of SURD. So before we go into that, let's take some notes. So the square root of a prime number are irrational numbers. For example, root 2, root 7, and let's say root 11. They are all prime numbers. They are all irrational numbers. Now the second point is the product of two distinct square root of prime numbers is also irrational numbers. So for example, which is root 3 times 5 equal to root 15. So it is therefore follows that the root 15 here is an irrational number. Now let's take a look at point number 3. So with point number 3, the mere presence of a root sign does not make a number irrational. So for example, root of 36 and so on are not irrational numbers. Point 4, a rational multiplication of an irrational numbers is an irrational form number. What's the meaning of this? So for example, 9 root 3, they are all irrational numbers. So that is the rational multiplication of irrational numbers. It's an irrational number. Now point 5, the square root of irrational number is rational. Let's take an example. So example is 5, the square root of 2 power 2 root 2, which is the same as 2. And they are all rational numbers. Now the last point is small numbers which neither terminate or non-recur, rational numbers. So one of the well-known irrational number is pi, right? So the value of pi is like 3.141592265 going onwards, like, yeah, so which has no repeating pattern. So the value of the pi is sometimes approximated by the rational numbers 22 on 7, or the terminating decimal has 3.142. right? Now let's go into the addition, subtraction, and multiplication of SURD. So if we consider root of the number 6, so let's consider the root of number 6 here. Now we know that 2 times 3, so the root of 2 times 3. Now therefore the square root of 6 can be expressed as the product of the square root of 2 and 3. That is, if you have the square root of 12, can also be expressed as times the root of 3, which is the same as 2, 3 here, the same thing. So in general, if k, which is also equal to root of m times the root of n, very simple. Now take note of this. Now the square root of a number is the same as the product of the square root of its factors. So, or if n is such that n can be expressed as the product of a perfect square and another integer, then the square root of 12 is reducible SURD. Let's take some examples. So if we have square root of 20, right? So with this one, how do we express it? So let's simplify this. So with this, we are going to get the square root of 4 times 5, which is the same as root 5, right? Now let's consider b. With b2, we can simplify it. So with this one, we have 9 times the square root of 5. Then we have square root of 9, which is 3, then 5, like that. Now let's consider c. You can pause the video and try to do the rest on your own. So with this one, we have root 2. And with this one, we have same as root 9 times root 7, and it's 3 root 7. Very simple. Now, let's go to addition and subtraction of SURD. Now, in algebra, two like terms can be combined to form a single term. So in the same way, we can also combine two like SURD. So let's consider, for example, if we have root 2 root 3 and 2 root 3 plus 6, 3, so this one's 3, can also be equal to 8 root 3. Right, so we just added the 6 and the 2 because we have the same like term, root 3, so we just add the outside one to get the answer. Very simple. So similarly, 8 root 2 minus 5 root 2 should also be equal to 3 root 2. So we just subtract the 5 from the 8, then we maintain the root 2. That's how we do it. So however, we cannot just combine unlike terms, such as if we have maybe root 4 root 3 and 5 root 2. You cannot combine because we have this is unlike term. We have root 3, we have root 2, so we cannot combine this. So let's take some examples and see. So with this example, we have root 3, 5 root 3 plus 6 root 3. So how do we do this? So we have like terms, root 3, so we can just combine them. So we just combine 5 plus 6 and we get 11. So 11 root 3. With this one too, we have like term 11, then 11. So we just subtract the 4 from the 3 and we get negative root 11, right? Then we have 6 root 2 plus 7 root 2 minus 8 root 2. So we have like term root 2, root 2. Therefore, we can combine them. So we have 6 plus 7, which will be 13 minus 8, right? Then you get 5 root 2. Then when we come here, we have to simplify it first to get the like term. So here we have root 80 plus root 20 plus root 45. So how do we do that? So here we have to simplify it. So root 80, we are going to get 9 times 5, right? Then when we simplify, we should get 4 root 5 plus 2 root 5 minus 3 root 5. So here we have like terms, so we can now combine them. So we have 2 plus 4, which is 6, minus 3, so which is 3 root 5. Very simple to do. Very, very simple to do. Now let's look at the multiplication of Z. So as we stated earlier, we said that the square root of a number, which is the same as root 2 times 3 and is equal to root 6. That's the reverse of the rule. Also, we can also reverse this one as root 5 times root 7, also the same as root 5 times 7. Then we get root 35, the same thing, right? Now another one is when we have maybe root 2 exponent the cube. So with that one we have root 2 times root 2 times root 2, right? Then when we combine 2 times 2, and we get 2 root 20, which is also equal to 2 times bracket open root 2 multiplying the root of 3 exponent 3. How do we do that? So we have root 2 multiplying the 3. So let me just clean this and do it straightforward. So we're going to have something like the square root of 2 times 3 times 3, right? Then when we do it, we should get 5 times 2 root 5 times 2, and when we simplify, we should get 20 root 10. Very easy. Now let's look at the last example. You can also try to pause the video and try to do it on your own. So with this one, we should get something like times 7 is 5 here. So when we do it, we should get 14. Then here we get 7 times 7 root 7. Simplify it, you get 14 multiplying 49 root 7, right? So when we do everything, we should get 2 root 2 on 7. Very, very simple to do. Now let's look at the last aspect of Z, the basic of it. Now we are going to talk about the multiplication of Z in the form of a plus b root n. So when we multiply 2Z in a bracket, we apply the rules of expansion, right? And we use the properties of Z to simplify it. That's how we do it. So let's take some examples. So if you have root of 2 multiplying 3 plus root 2, how do we do that? So with this one, we should get something like 3 root 2 plus what is in the bracket root 2 squared, which is the same as, let me use the black color here, which is the same as 3 root 2 plus 2. Then with this one too, it's gonna be 3 times 2. You remember that? Then open bracket root 3 squared. Then we have root 6 minus 3, right? So you can see that we have the a. So a here is 2 and the b here is 3 and the root of n is root 6. You can see that it's in the form of that. Now with the last question, we have 3 root 2 multiplying 4 root 2 plus 2. How do we do that? So 6 root 2, right? Then when you simplify it, we get 24 plus 6 root 2. So in the form of a plus b root n, we have our a to be 24, b to be 6, and root of n to be root 2. You can see that. So this is the end of this video. Watch my next video where we go deep into Z. Thank you for watching this video.